Okay, let's start off with a few questions from quarter one. Alright, so changing radicals to exponential form. So here's what you gotta remember. Anytime you have exponential form, so if we have like 3 to the 2/3, and your exponent happens to be a fraction, if you morph that into radical form, you're going to have a radical. The base is going to be what's under the radical, and then your 2/3. The 2 goes here, and the 3 goes here. So it's the cube root of 3 squared. So if you want to go from radical to exponential form, if we've got like this guy, and if you morph that to exponential form, the exponent, if there's not one, it's understood to be a 1. And the index, if there's no index, it's understood to be 2. So this would be 6, and the exponent would be 1/2. So anytime you have an exponent that's a fraction, what's really going on is some kind of a radical. So here we go, ABC. Square root of 9. Okay, square root of 9, that's a perfect square. Square root of 9 is just equal to 3, or 3 to the 1. So that's kind of a trick question. B, okay, now all the pieces are there, we just got to put them in the right spot. So 2 is going to be the base, and 4/5 will be your exponent. And C is a little bit tricky, because they're saying 3 is the base, but what we have here is 81. So let's break up 81. 81 is 9 times 9, and 9 is 3 times 3. So I'm going to swap out 81 for this. So it's really this. It's really the 5th root of 3 to the 4th. Okay, now our pieces are all there. So the base is 3. That matches up because that's 3. And it should be, again, should be 4/5. Okay, so now you're given 3 expressions in radical form. Change them so that they're written in exponential form. So this is understood to be 2. So this would change to x to the 7/2. This one would change to x. This is the numerator. Your index is on bottom, to the 5/3. And then the very last one would be x to the 9/7. Okay, let's go the other way around. So now they're given an exponential form. Let's rewrite them to radical form. So you're going to have a radical, and that is your base. So that's our radicand. That goes right here. And then 1 here, and 2 would be the index. So it's a square root. This would be x squared underneath, and this would be a cube root. And the last one, x is underneath, x to the 7th, and it is a 4th root. Okay, so those are not bad. Just gotta know where each piece goes. Now, some imaginaries. Let's simplify these imaginaries. This first one, anytime you see a minus, let's think of it as a negative. So let's rewrite this. Let's go 6, and let's not do subtract 8i. Let's do plus a negative 8i plus a negative 8 plus a negative 3i. So put pluses there, and let's look at these minuses as really negatives. So now you're like terms. 6 is a real number, and a negative 8 is a real number. So these two play together. So it's 6 plus a negative 8. Now the 6 plus negative 8 is going to be a negative 2. So those will clean up and give you a negative 2. Okay, now these are like terms. You got some imaginaries here, and you got some imaginaries here. So these will play together. So if you have a negative 8 imaginaries plus a negative 3 imaginaries, your total is a negative 11 imaginaries, and that is your answer, because you cannot combine imaginaries with reals. They're not like terms. So this one's pretty easy. All you do is just add like terms. A negative 2 plus negative 11i, that's the same thing as negative 2 minus 11i. So you got negative 2 reals and negative 11 imaginaries. Okay, now the middle one is a little more difficult. So this is a times right here. You've got to times this one to this one, and you have to times this one to the negative 7 imaginaries. So timesing's pretty easy. Just times your numbers. 2 times 2, that's 4, and you have an imaginary, so 4 imaginary. Now you got to do 2 times a minus 7, which is a minus 14. But now you have I times I, and I times I is tricky. In the imaginaries, you got to remember two things. I times I, if you have an imaginary times imaginary, it will always turn real. Imaginary times imaginary is I squared, or it is a real negative 1. So if you have I times I, that's going to turn to a real negative. So this is what you got to remember, that I times I is negative 1, and you got to remember this: square root of a negative, that is imaginary. Anytime you got the square root of a negative, that is the definition of imaginary. So you take the negative out, and that is imaginary. Then you just do the square root like normal. So square root of 1 is just 1, so that is 1 imaginary. So 1 imaginary is really the square root of a negative 1. So if you got the square root of a negative 4, take the negative out, that is imaginary. Then you just got square root of 4. Square root of 4 is 2. So that is really 2 imaginaries. So anytime you got a negative under square root, that's imaginary. And if you ever have imaginary times imaginary, that turns to a real. So here's what I got so far. I got 4 imaginaries plus, so this I times I is really a negative 1. So it's a negative 14 times a negative 1. And a negative times a negative is a positive, so that's 14. And that's 14 real. And then I got at the very end right here, plus 4 imaginaries. So you got 3 terms. Add your like terms. 4 imaginaries at the start and 4 imaginaries at the end. Those are like terms. And 14 real is done. You should have 14 reals and 8 imaginaries. And that is your final answer. Okay, then the last one. So radical, simplifying a radical 12. If you got numbers, you always break them down to see if there's squares in there, and you got to pull the squares out, because this is a square root and it will undo any square. So if you got 12, that's the same as 3 times 4. 3 is done. 4, that's a perfect square, because that is 2 times 2. So you're going to exchange 12 for 3 times 2 squared. You've got a perfect square right here. This square root is going to undo this square, so 2 comes out. Okay, now on the outside, you've already got a negative 2 times p, and you're bringing a 2, that comes out. So whatever is out there, you times it all together. Okay, now on the inside, that 3 stays left over. Okay, now p to the 5th, that is p, 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 p. You got 5 of them. That is a square right there. That is a square right there. So that's the same thing as 3 times p squared, p1. There's 5. 2 here, 1 here. 5 p's total. So this square root undoes that square, so this p comes out, this p comes out. So I'm bringing 1p, 2p's out. Okay, now everything on the outside you times together. So your final answer, on the outside you got a negative 2 times 2, that should be a negative 4. Then you got p times p times p, so that's p. When you times letters, you add 1 plus 1 plus 1. This exponent's a 1, this exponent's a 1, this exponent's a 1. So anytime you times letters, you add up the exponents. So you should have p cubed. And then on the inside, that's everything on the outside. The inside, we just got this 3 here. And you got a p left over. And that is your answer. Okay, and that should be it for the review from first quarter. The rest of this stuff is stuff we've introduced in quarter 2. So factoring, let's change all these to times problems. So, there we go. Okay, first of all, so look at this one right here. 5n squared minus 65n plus 150. Always see if you can shrink it down. So these each can be divided by 5. So before I do anything, I'm going to divide each of the 3 pieces by 5. So if I rewrite it as a times problem, it's going to be 5 times all the leftovers. So if I divide 5 by 5, the leftover is just 1n squared. Okay, now I'm going to get a calculator. Negative 65 divided by 5 is a negative 13n. And then 150 divided by 5 is 30. Okay, now let's see if we can go again. So now this starts with the 1, so I really like it. So here's what I'm going to try and do. We're going to go 5. We're going to try to break this up into 2 factors. So we're going to go like this, and it's going to be timesing to get n squared, so that's just n and n, because n times n is n squared. Okay, now you got to get your factor sheet out, and you got to look at 30. So here's what you're looking for right here, 30. It's got to times and give you 30, but it's got to add and give the middle. So it's got to add and give a negative 13. So if I start looking through my choices for 30, your choices for 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, now one of those 4 options, you've got to create a negative 13, and you can create that with a 3 and a 10. So we're going to use 3 and 10, but they've got to add and give you a negative 13. So it needs to be a negative 3 and a negative 10, and that will work because at the same time they've got to times and give you a positive 30. And the only way you can times and get a positive is if you do a negative times a negative or a positive times a positive. So that's it. Negative 3, negative 10. Okay, that's the answer. Those are the factors. Now factoring, you can always check your work. You'll know you have the right answer. So if you take just a minute and check your work, so if you start timesing through n times n, that's n squared. N times a minus 10 is a minus 10n. Minus 3 times n is a minus 3n. A minus 3 times a minus 10 is a plus 30. And if you add your like terms in the middle, that's n squared minus 13n plus 30. And then the last thing we had to do was times it all by 5. So that will create a 5n squared. That will create a minus 65n, and that will create a 150. So if you times it through and get your answer, you did it right. Okay, the number 2, this guy in the middle. See if you can shrink it down. 2, 15, and 25. and they got nothing in common. So you cannot shrink it down. This is a perfect square. You can do square root. Sometimes they're special if the start and the end. This is not a square root, so that's not a special case. So here we go. This does not start with a 1. If it does not start with the 1, we are going to take this piece, copy paste, 2m squared. We're going to take the middle, we're going to break the middle into 2 pieces. So we're going to go plus something, the end, copy paste. So the very beginning and the very end, copy paste. You're going to turn it from 3 terms, 1, 2, 3 pieces, into 1, 2, 3, 4 pieces. Okay, now get your factor chart out and take the very first number, 2, and times it to the very last number. 2 times 25. Okay, my target number is 50. So start looking at your options for 50. 50 does not have very many options. 1 and 50, 2 and 25, 5 and 10. Okay, now you got to choose the option that when you add is going to give you 15. So when you times them, it gives you 50, but when you add, it gives you 15. So we're going to go 5 and 10. So right here, I'm going to go 5m plus 10m. Okay, now once you've got that turned into 4 pieces, 1, 2, 3, 4, you're going to group them. So I'm going to group these two together. So if I go 2m squared plus 5m, okay, 2 and 5 have nothing in common, but these both have some letters. So all I can factor out is an m. So if you factor m out of each piece, it's going to be m times 2m plus 5. Okay, now let's do the next group. So this next group, this guy, the 10m plus 25, I can divide out of both those terms a 5. So if you divide a 5 out of each of those terms, it's going to be 5 times 2m plus 5. Okay, now look at this. Look at group 1 and look at group 2. Group 1 and group 2, they both have a factor 2m plus 5. So your final answer, we're going to factor out of both of those a 2m plus 5. So 2m plus 5, and if you factor out a 2m plus 5, your leftovers are going to be m and 5. It's going to be these guys out front. And this is your answer. So if it does not start with a 1, so this would be the A, your A, B, C, A, B, C. A is 2, B is 15, C is 25. Anytime that your A is not 1, and you can't shrink it down, turn the 3 pieces into 4 pieces and do grouping. So you got to times the first number times the last number, A times C, that gives you 50, and then go through your options and figure out which option will times and give you 50 but add and give you 15. Okay, this one right here, this one is a special case because that's a square root and that's a square root. So if they're special cases, they're not bad at all. So you just take the square root. Alright, square root of 4x squared, that's going to give us a 2x. That gives us 2x. And then square root of 25 is going to be 5 and 5. But it's got to times and give you a negative 25. So 1 is positive, 1 is negative. And let's check it real quick. 2x times 2x, that's 4x squared. 2x times a negative 5 is a negative 10x. 5 times 2x is a positive 10x. And a negative 10 and a positive 10, that's 0. That's why there's nothing in the middle. And 5 times negative 5 is a negative 25. Okay, that worked. Bottom left. Okay, bottom left. Okay, we got 4 pieces, so we're going to use grouping. So I'm going to let's group these two together. So if you group 5p cubed minus 10p squared, let's divide out of both those. Let's take a 5 and some p's. Let's take, this has p cubed, this has p, let's take p squared out of each. So if you take a 5p squared out of each, it's going to be 5p squared times 1p minus 2. Okay, now your next group, this 6p minus 12, factor out of both those a 6. So it's going to be 6 times 1p minus 2. So now we're in shape because both terms have a 1p minus 2. So your final answer is going to be 1p minus 2, and then the other group will be 5p squared and 6. Okay, last one. Last one's kind of like this one. That catches your eye and that catches your eye, so it might be a special case. Let's check it to see if it's a special case. If it's a special case, you just take square roots. So if it is a special case, they get 25b squared by going 5b and 5b, and they get 16 by 4 and 4, and your signs, everything is positive, so these must be positive. Okay, now let's see if that really does give 40 in the middle. So if you go 5b times 5b, that's 25b squared. If you go 5b times 4, that's 20b. And if you go 4 times 5b, that's another 20b. So that looks good. 4 times 4, there's your 16. 20b and 20b. So you got 25b squared. Those will give you 40b. So we checked it real quick, so we know that's the answer. So if you've got 5b plus 4 and 5b plus 4, that's a perfect square. You can just write 5b plus 4 squared. Or you can write it out the long way. Either way is fine. Okay, find ABC, AHK. So these two forms are a big deal. So one of them is called standard. Standard is ABC. So if we put it in standard form, we arrange our pieces, the square first, then the linear, then the numbers. Vertex. Vertex is awesome for graphing. Vertex, A in both cases is kind of the same. A affects your slope and your orientation. X minus H squared plus K. Okay, so find all of it. ABC, AHK. So if you look at this, it is given to you in this one. So A is how many squares you've got. So in front of the square, there's no number. It's understood to just be 1. So A is 1. B is how many x's you've got, how many linear pieces you've got. So B is going to be a negative 20. So you find the x to the 1 and the number in front, the coefficient, so negative 20. C is how many 1's you've got, number all by itself with no letters. So C is going to be 2. Okay, so that's kind of given, but now the A is always, if that's 1, this A's got to be 1. A's not going to change. It's your H and your K. So you're going to have to manipulate it a little bit to find H and K. And here's how you do it. You're going to go x squared minus 20x. Okay, this is a perfect square. You've got to create a perfect square, kind of like we just barely factored. So x squared minus 20x, let's just take the 2 and scoot it over. Okay, now you're going to create a perfect square, so it all depends on the middle. and this middle is a minus 20. So you take the middle and you cut it in half. They get the middle by addition, so this must have been like a negative 10 plus a negative 10. And they get this piece by timesing, so it's going to be a negative 10 times a negative 10. So the number I want right here is 100. Okay, 100 will make it a perfect square now. So if I'm going to add 100, I really need to add 0, because I can't just go changing equations. So I'll add 0, add 100, and then 1 second later, subtract 100. Okay, now these two play together. So minus 102, that gives you a minus 98. Okay, now these three play together, and if you factor these three, that will factor to x minus 10 times x minus 10, and that's a perfect square, so you can write that as x minus 10 squared minus 98. Now this is in vertex form. So your a is right here, a is 1, your h is in the parentheses, but your h is after the minus. This h is the hardest one to find, because in your model there has to be a minus. So in my model there is a minus, so I'm in good shape. So my h is only 10. It's not a negative 10, it's 10. And the k is this guy on the outside, so k would be a minus 98. So that's not too bad. Okay, and let's go. Okay, now this one, they gave it to you in vertex form. So a is 1. Now this is tricky. This is really x minus. There has to be a minus in your model. So it's x minus a negative 4 squared plus 3, and a minus a negative. That's really a plus. So your h is always after the minus. So your h is actually going to be a negative 4. And your k is 3. Okay, now ABC is going to be actually way easy to find. ABC, we're going to go backwards. So if you've got x plus 4 squared plus 3, to find ABC, you just expand it. So you're just going to go x plus 4 times x plus 4 plus 3. So if you distribute this out, that will give you ABC. So x times x, that's x squared. X times 4, that's 4x. 4 times x is another 4x, and 4 times 4 is 16 plus 3. So now let's combine up our like terms. You're going to have x squared, 4x and 4x, that's 8x, and then 16 and 3 play together. 16 and 3 is 19. So this is standard form. So your a is 1, your b is right there, your b is going to be 8, and your c is the 1s. So c, you've got 19 1s. So it's probably easier finding ABC if they give it to you in vertex form. If they give it to you in standard form and find AHK, that one takes a little more creativity. Okay, now when it's given to you in vertex form, it is super easy to graph. So first let's identify the A, the H, and the K. So A is right here, A is 1. H is not 3. H is always kind of opposite what you think it is. H is a negative 3, and K is a minus 2. Now you start here at 0, 0. Your H and K are your vertex. Negative 3, negative 2. That is your H, that is your K. Your H is your X, which goes left and right. Your K is the Y, which goes up and down. So you put your H and K together, start at 0, 0. You should go left 3, 1, 2, 3, and then go down 2, 1, 2, And that is your vertex right there. Okay, now you're going to use your slope. Your slope is 1, so you're going to go up 1 over 1, dot, dot, and your parabola looks something close to that. So let's do the same thing. Graph the function x squared plus 8x plus 12. Now this one's tricky because they gave you a, b, c. A is 1, b is 8, c is 12. So I really want a, h, k, because a, h, k is super easy. So here we go. You're going to go x squared plus 8x. Scoot the 12 over. Okay, now 8. If you cut 8 in half, that is 4 plus 4. So the number I want is 4 times 4. I want a 16. And if you add a 16, you got a minus a 16. What's up? Now these three play together. If you factor these three, that's going to be x plus 4 times x plus 4, x plus 4 squared. These two play together, and that's a minus 4. So now your a is 1, your h is a minus 4, and your k is a minus 4. So that means h and k, that's the x, that's the y, so go left 4, down 4. And there is your vertex. Now use your slope 1 over 1, so go up 1 over 1, kind of the same, and looks like that. That's too early. I know. Alright, so translation. So we're going to take what's given, we're going to slide it around. So here is what's given, this guy right here. So on this one, your a is a minus 2. Your h, see you later. H is a minus 3. And your k is a minus 2. So now look, if you graph this one, kind of just draw my own graph. So your h and k, negative 3 and negative 2, your h is the x, the k is the y, so we're going to go left 3 and down 2, dun, 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 right there. But now this time your slope is a negative 2 over 1, so that means you're going to go down 2 over 1, so it looks like this. And that is what's given. So you're going to take what is given and you're going to translate it. And here's the translation. Go 2 units left and 2 units down. So you're not changing the slope at all, you're just changing, so it's like a copy paste. So 2 units left, 2 units down. So take this vertex, go 1, 2 to the left, 1, 2 down, and its new location should be right there. So its new location, I need the new location. I need the new A, the new H, the new K. The new A, the A did not change, so A is going to be negative 2. H, I went 2 more to the left. So instead of going 3 to the left, I'm actually going to go 5 to the left. And the K is down 2 more. So instead of going down 2, I'm going to go down 4. So here is my new A, H, and K. So if I put that into an equation, it's going to be y equals A times x minus the h, which is a negative 5 squared, plus the k, so plus a negative 4. So this minus minus, that's actually a plus. This is the equation we're looking for. And that would be, I guess not y, that would be g of x. So there's the equation of g of x. Let's do the same thing for 7. Okay, I'm going to kind of graph it myself. So let's find the given a, the given h, and the given k. So the given a is 1. The given h is a 2. And the given k is 0. There's no number out here. So that means start here at 0, 0. Go over 2, and do not go up or down. And your slope is just 1 over 1, so it looks something like that. Okay, that's what's given. They want you to reflect as a flip it over the x-axis, and then go 4 units left. So if you flip it over the x-axis and go 4 units left, right now I'm over 1, 2, so I gotta go 1, 2, 3, 4. So there's my new home. Then you gotta flip it so it looks like this. Okay, so your new A, your new H, and your new K. So you did not change the slope. So the slope is still 1, but you just changed the orientation, the direction, so put a negative. Okay, your H is totally different. Your H before was 2 to the right, and now it is 2 to the left, so your H is a negative 2, and your K is 0. So if you plug them in, this is going to be y equals A times x minus h, which is a negative 2, squared plus k. And I guess we don't need the plus 0. And a minus minus, that is a plus. So x plus 2 squared times a negative 1. Okay. Give me the equation for this problem in vertex form. Vertex form, you need A, H, and K, and there is the HK. So to get to this dot, I go left 1 over 1. You start at 0, 0. You're going to go over 1 and down 2. So your H and K are super easy to find. H is negative 1, K is negative 2. A is your slope. So from here, this dot up 1 over 1. So dunk dunk. So your slope is 1. And it's positive 1 because it opens up. So that means my answer is y equals 1 x minus 1 squared minus 2. And that will be a plus. Sounds pretty easy. And then roots. Okay, your roots are your zeros. They are your x-intercepts. There is a root right there, and there is a root right there. So to get to these two dots, if you have a table, to get to this dot, I go over 1, 0. 1, 0. That's why we call it a 0. Anytime your y is a 0, that's going to give you a root. And to get to this dot, it's a negative 2, 0. So negative 2, 0. These are a big deal. So your roots are what give you 0 for the y, and they're easy to find if you're looking at a picture. Now your x-intercepts, they're where the parabola crosses the x number line. So your roots are these guys right here. And you don't even need to write the negative 2, 0, 1, 0. You could just say negative 2 and 1. Those are your roots. Okay, last one. Find the roots. Find the zeros. 2 ways. Find them by factoring and then by quadratic formula. So factoring, first of all, you got to get everything on the same side. So I got to move this over. You got a minus n, and that will match up with the 14. So minus just 1n. And on the right, you have 0. On the left, you have n squared, a minus 14 and a minus 1 is a minus 15n plus 56. Okay, now we're going to factor it, which is hopefully easy. So you're looking for 56. So look at 56, get your factor chart out. 56, how many options we got for 56? We got 4. 1, 56. We got 2, 28. And we got 4, 14. And then we got 7 and 8. So you got 4 options. You got to choose an option that's going to add and give you a minus 15. So now look, it's got a times and give you a positive. So I know that they both have got to be positive, or they both have to be negative. In this case, they both have to be negative. Right there. if I do a negative 7 times a negative 8, that is a positive 56. But if I do a negative 7 plus a negative 8, that is a negative 15. So, there we go. N minus 7, n minus 8. That's how it will factor. Now look, you got to find the zeros. You got to find the roots. So that means this. If you have this times this and your answer is 0, the only way you can get 0 for an answer is if you times by 0. So now you got to figure out, what are you going to put in place of n to create a 0? So right here, if I take n out and I put in its place a 7, you got to do both of them. 7 subtract 7 is 0. And 7 subtract 8 is a negative 1. And 0 times a negative 1 is 0. So one of them is 7. And the other one is going to be 8. Those are your two roots. Because right here, if you take n out and you put in an 8, 8 subtract 8 is 0. And you put an 8 here, 8 subtract 7 is 1. 0 times 1 is 0. So those are the two ways you are going to get zeros. Okay, now you got to get the exact same answer doing the quadratic formula. So over here on this side, I'm going to do quadratic formula. So quadratic formula. We got to find ABC. A, we're going to use this right here. A is 1. B is a negative 15. C is 56. Okay, now once you get your ABC, you just plug it in. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So make sure you've got that in your notes. X equals negative b plus or minus the square root. Put b in parentheses. B squared minus 4 times a times c all over 2a. Okay, now look, you know the answers are integers. Your answers are easy. There are no funky decimals, no square roots, no imaginary. So that means we're going to have a perfect square. So here we go. It's got to be negative b. So negative, now put b. And b is a negative. So that's two negatives in a row. That should really be a positive 15. Plus or minus the square root. Put b in parentheses. So let's go parentheses. B is negative 15. Parentheses squared. And I'm going to change this minus to a negative. So I'm going to go plus a negative 4 times a 1 times c 56. And that whole thing is divided by 2 times a. Okay, now this, I'm just going to type this underneath the square root. I'm going to type that in on my calculator and clean that up. So I'm going to go negative 15 squared plus a negative 4 times 1 times 56. And that should clean up to give you 15 plus or minus square root. All of this under the square root cleans up to be 1. Divide that by 2. Okay, now you've got to do two you got to do two options. You got to do a plus and you got to do a minus. You love square root of 1. Square root of 1 is just 1. So square root of 1 is just 1. So we're going to do this. We're going to do 15 plus 1. Then you divide that by 2. Then you got to do 15 minus 1. And you got to divide that by 2. So you got to do 1 for the plus, 1 for the minus. So 15 plus 1. That's 16. 16 divided by 2, there is our 8. Same 8 we got here. 15 minus 1, that's 14. 14 divided by 2, that is 7. The same 7 we got there. Okay, now I'm out of time, so I'm going to stop there. So this next one, this last one, do on your own and bring back to me and let me check it. So do the same thing for negative 4r squared minus 8r plus 20 equals 5 minus 5r squared. Get everything on one side equal to 0. Factor it. Then find A, B, C, and plug into the quadratic formula. You should get the same answer. So this last one, bring it back to me, let me check it.